So today we're going to talk about waves basic or basic waves. Alright, a wave is a disturbance that takes place in one area and then moves energy to another. Alright, if you see a wave in the ocean, it's actually not the water moving, it's the energy underneath that's moving it. So when you look out there, it's just the water going up and down. The water's not moving. A good example of this is if you take a rubber duck, you put it in a big bowl of water, and you drop something in the water. The rubber duck would just move up and down. So a wave is not pushing that duck. It's just moving the energy across the whole bowl. All right, so some basic examples of waves. There's ripples in water, which I just talked about. So when you drop something in, that ripple. Sound. Sound waves. So when you talk, it's in a wave. The other one is light. Now all of these are in different types of waves though. So we have our waves. When it comes to our waves, we have two different types. We have mechanical waves. I think that's how you I'm not a very good speller. Close enough. And then we have electromagnetic waves. So your electromagnetic waves, what really does separate these two is the electromagnetic waves can travel through a vacuum. What that means is they can travel through outer space. They don't need a medium. Mechanical waves do need a medium, such as a solid, such as a liquid, or a gas. All right? Electromagnetic waves do not need any of those. If they did need a medium of some sort, then we would all freeze to death because heat from the sun could not get to us using radiation. That's the way heat travels from the sun. Right? So examples of the electromagnetic are, you can probably think of it, light. Right? Light does not need a vacuum, or it can travel through a vacuum. It doesn't need a medium. If that was the case, we wouldn't be able to see anything in the sun ever. Right? Just no light would ever come off the sun. Right? I don't know if that's the best example of it, but light. That's the one you usually use. Alright? The other type is mechanical. It needs a medium. Alright? A medium is a solid, liquid, or gas, like I told you. Sound travels faster through a solid than it does a gas. Alright? Because all of the particles in a solid are tightly wound together. So when you hit one, it automatically hits the other one. So if you have a gas, you have a particle here, it hits it, it takes a second. So it actually travels faster through a solid. That's why in old movies you see them put their head to the ground so they can hear the horses coming. Alright, back in westerns, or they put their head on a railroad track and you can hear it coming. I'm not saying do that. Please do not go put your head on a railroad track. But you can hear the vibrations of the train far away because it's traveling through a solid, which is your medium. There's two types of waves. They are longitudinal, and the other one is called a transverse wave. Longitudinal wave, the best example of it is a slinky. But we'll talk about those later. And a transverse wave is the one you're probably used to seeing. Alright, so how these waves happen is it needs an original disturbance. And that's also called the pulse. A pulse, by example, is a single non-recurrent wave. Alright? Every wave needs a disturbance to start. A wave just doesn't happen. Alright? You just don't look out to the water and just sitting still. If you're looking at a lake and there's nothing in it, no wind, nothing, it just doesn't start moving. When you throw a rock in it, it creates ripples. It needs an original source of disturbance. So, a pulse, just one, I have my jacket here, I don't know if you can actually see it. So, that's a pulse. What a wave is a consistent series of those pulses. It's like when you take a jump rope and you flick it once, or you see those guys doing CrossFit and they're that's a pulse, just one. So what a wave is actually a series of those pulses over and over and over, consistently. Now they die down with different things. We're talking in an ideal situation here. It's just forever and ever. All right, a good example of a transverse wave is sound. That's the one you hear the most from it. There's a bunch of different types, but we'll talk just sound. All right, so I have a transverse wave here. This area through the middle is called my medium. Other people have names for it. So these top portions are called crests, or the system we use says peaks. The bottom portions called troughs. And again, I think that's spelled right, but I'm not really sure. I'm a terrible speller. Alright, that's basically a transverse wave. In another video I'll talk about amplitude, frequency, wavelength, stuff like that. But this is basically just what a transverse wave is. Now this is a longitudinal wave. The best example everybody always uses this is a slinky. You take a slinky and you give its energy out. Alright? It shrinks once it hits the other end, it'll shrink. It has these little areas here. And these little areas are called compressions. It's pretty simple to remember. And the parts where they're really spread out are called rarefactions. I think it says they're rarefied or something like that, but the rarefactions are the spread out part. The compressed parts are the compressions. But the slinky is the most common one. And the last wave I'm not going to talk about, just mention a circular wave. It's when you take like a rope and kind of twirl it around and make a circle. But those are basic types of waves that you need to know about. And crest peaks, rarefactions, and compressions. Alright, this has been very basic waves. In the next video I'm going to go over all the different parts of the waves and speed and stuff like that. So I hope this helped, and good luck.